So we're studying organic chemistry, and alcohols is another one of our homologous series that we need to know about. This video hopefully will help you fill in the bits in your booklet that you're doing this week. So on this post note you can see that the functional group in all alcohols is the OH functional group. That's what makes it an alcohol. If we look at our first member of the series, it's called methanol. So this is the structure of it. It's got one carbon and then that OH functional group that's on the end. And the formula can be written as CH3OH. Now, in your book it asks you what state it is at room temperature and pressure. So here's one out of the prep room. So you can see methanol is a liquid at room temperature and pressure. So the next one then along our series is ethanol. So you see it's got two carbons joined with it. And just like an alkane, only it's got one of the hydrogens being replaced with this OH functional group. And the formula for ethanol is C2H5. And if we look our example of ethanol, then what state it is at room temperature and pressure. Hopefully you can see it through the colour of the bottle. It's a liquid as well. Okay, now then we come to the third one. And what's different about the third one is where we can find the functional group. Okay, these two molecules, if you want to pause the video and have a look at them, you will notice that they are different molecules. While they might contain all of the same atoms, the atoms are actually arranged in a different position. It's what's known as a position isomer that you'll learn whenever you do AS chemistry, what a position isomer is. So with this one, the OH group is on the first carbon along the chain, whereas in this one, the OH group is on the second carbon along the chain. So they're both called propanol, but instead, so that we know which one is which, we call this one propan-1-ol because the OH group's on the first carbon. That's where the propan-1-ol comes from. And then, this one is propan-2-ol because the OH group is on the second carbon of the chain. So this formula, the molecular formula, is the same for both. But then if we were writing out the formula to show the difference between the two, we would write it like this. So these formulas show you the OH on the end of the chain, and this one shows you the carbon in the middle of the chain has a hydrogen joined to it and the OH group in the middle of it. Now both of these liquids, or both of these, this is propan-1-ol exists, and then propan-2-ol, which we don't have just as much of in the container, but they are both liquids at room temperature and pressure. So hopefully that answers that table on page 22, all about the alcohols that we have. So we're going to look at carboxylic acids, which is our next homologous series in our topic. So it's in your booklet, it's on page 26 and the start of page 27 there with the table that hopefully this video will help you fill in. So you'll see here on the post-it note that the functional group in this homologous series, the functional group for carboxylic acids is a COOH group. That's what makes them all carboxylic acids. So we're going to run through some examples of them, the structure of them and the formula. So the first one we're looking at is methanoic acid. So it has one carbon atom. And then this is what the COOH group looks like. So a carbon double bonded to an oxygen and then single bonded to the oxygen and hydrogen. Okay, so the name of it is methanoic acid, and the formula can just be written with HCOH. So you can see how the structure and the formula links together, and you can see it's drawn nicely in your booklet for you. And then I asked you about the state at room temperature and pressure. So here's in the fume cupboard I got out of the prep room today. And the methanoic acid is a liquid at room temperature. So the next one in our series is ethanoic acid. So two carbons this time, and then the COOH group on it. The formula is CH3COOH. Now, a common name for ethanoic acid is vinegar. If we're back in the lab, I'll get you to smell some ethanoic acid. It's different concentrations then depending on what we use it for. So obviously this is an irritant. You can see it's made up, it says irritant on the bottle, so it's not the sort of thing that you'd put on your chips. It would have a different concentration in the acid, the ethanoic acid you use for your chips. Okay, the next one then is propionic acid. So we're increasing our carbon chain length. We now have 3 carbons and our COOH group at the end, and the formula is C2H5COOH. And again, the state at room temperature and pressure, hopefully you can see it in the bottle there, it's liquid at room temperature and pressure. Then the last one that we're looking at is butanoic acid. So again, 1, 2, 3, 4 carbons which means it starts with but, and then the COH group. So the formula for it is C3H7COH. And again, a smaller bottle of this one this time, but it's still a liquid at room temperature and pressure.